Yes, Taylor in multiple dimensions. First, I'll do the Taylor series, then clarify again what a Taylor polynomial is, and then give an example up to degree 2. In the playlist about Taylor, you'll also find all the basics. We're dealing with the multidimensional case now. Let's start with the Taylor series. The series is an infinite sum. So t infinity x equals the sum from alpha equals 0 to infinity of 1 over alpha factorial. So times d alpha f of a d alpha f now stands for the partial derivatives times x minus a to the power of alpha, and a is the expansion point. Yes, remember we are now in multiple dimensions. So Taylor polynomial is a finite sum. I think you usually have to specify it up to degree 2, as I said. I'm writing f of x now. Yes, wait, in a moment we'll expand it as a sum from alpha less than or equal to k for the kth Taylor polynomial. Therefore, 1 over alpha factorial times d alpha f of a times x minus a to the power of alpha plus. And now comes the remainder term kxa. And here is the Taylor polynomial. Yes, accordingly here in this statement, and then up to which degree? Up to the kth degree. Here is the Taylor polynomial, which is not exact. No, because no, only if we, run the series to infinity, yes, then we would have an exact result. Here we also need, the remainder term with an estimate for the remainder. Another topic also included in the playlist. And now the Taylor polynomial here, ttk of x is given for tt2, yes. So accordingly, starting from 0, plug in 0, then plug in 1, then plug in 2, we start at 0. That would lead here to f of a, where a is the expansion point, yes, important. The expansion point plugged into the original function plus, and now comes the gradient of f at a transposed. What does all that mean? The gradient, the values of the first derivatives transposed corresponding to the vector for the multiplication x minus a plus 1/2. I think that's clear. We have 1 over alpha factorial, and for 2 factorial is 2. That it's 1 before, otherwise maybe check again, but that should be clear. Accordingly, times x minus a transpose times, now comes the Hessian matrix times x minus a. What is the Hessian matrix there as well? I'll link again to a relevant video, the second derivatives in a form that I can multiply out. We then have the linear approximation here, and we've also included the curvature here again. And here is a typical example of the specification for Taylor up to degree 2. And I think with the corresponding exercises, you'll hopefully also say, once you know the math term, there's nothing to worry about. And hopefully you'll also get through this topic, especially in multidimensional analysis, quite easily.